Hey folks! Welcome to this tutorial on Python. Let us quickly recollect what we have learned till now. We learned that Python is a multi-purpose programming language. It has its applications in a lot of domains. Python is dynamically typed. The data type of a variable is determined at runtime. Also, there is no need to declare the variables. It is an interpreted language. This means there is no compilation step, and the code is executed line by line at runtime. Python is built on the principles of code readability and understandability. Code blocks use indentation instead of braces or keywords. Python supports procedural, functional, and object-oriented programming paradigms. Developers can choose the paradigm that suits the task at hand. Python is platform independent. No modifications are necessary when migrating the code from one platform to another. Python finds its applications in a lot of domains. Availability of a huge set of third-party libraries, in addition to the already vast standard library, makes it easier to develop code in Python. Python is used widely in the world of data. Data analytics, statistical analysis, machine learning, data science, and artificial intelligence are the various data fields in which Python is used predominantly. Web development in Python is made very easy by Django and Flask libraries. It is much easier to automate boring stuff with Python. It integrates seamlessly with most tools and software products. Other applications of Python include file management, web scraping, networking, and scientific computing. Python is also used in developing games. Though not as fast as C++, Python is still used in prototyping of games and in development of 2D games because of the ease and speed with which games can be developed. Python has flexible and versatile data types. A data type can hold arbitrarily large values without any limits on the size. For example, int datatype can hold any large whole number. There is no such thing as long or double to hold larger values, as is the case with some programming languages. Float has a default 16-digit precision. It can be further extended using fractions or decimal library. String is the text data type. It is immutable. Python has sequence data types. There is no need to define the size. Size is dynamically adjusted when the sequence is initialized or updated. Lists and sets are mutable. Lists are denoted by square brackets, and sets are denoted by braces. Lists can contain elements of any data type. A list can have another list as an element. Sets can have unique elements, and the elements should be of immutable data type. Tuple and frozen set are immutable versions of list and set, respectively. Tuples and frozen sets, once initialized, cannot be updated. Range is a Python data type, which holds sequence of numbers. It generates numbers at runtime, and is not stored in memory. It has a start-stop-step syntax, and the upper bound, stop, is always excluded. Dictionaries are a collection of key-value pairs. They are mutable, and the lookup of any key in the dictionary has the same time complexity. True and false are the Boolean values. Empty strings, zeros, and empty sequence data types evaluate to false. Bytes and byte array data types are used to work with binary data. Bytes are immutable while byte arrays are mutable. The input statement in Python always accepts data in string format. Print is the output statement in Python. Index position starts from 0 in Python. Type conversion is supported, but if the data contains incompatible characters, an error is raised. F-strings are a clean way to embed expressions inside string literals. They are available in Python 3.6 or later. Extracting a part of a sequence without affecting its memory is called slicing. Slicing also has a start-stop-step syntax. As is the case with the range object, upper bound is excluded. Python supports negative indexing as well. Check out the previous video on data types if necessary. Now that we have quickly summarized what we learned, let us jump into decision-making and looping. Before we do that, let us understand the operators, which form an integral part in decision-making and looping. Python has the following classes of operators. Let us take a look at them, one by one. Arithmetic operations are an integral part of any program. All arithmetic operations involve two operands. Addition, subtraction, multiplication, and division are the most common arithmetic operations. There is a floor division operation, which returns only the quotient in integer format. Modulus returns only the remainder. Exponentiation returns the value of first operand raised to the power of the second operand. Assignment operators are used to assign values to a variable. Normally, equality would be the only assignment operator. But Python supports a couple other assignment operators as well. For example, let us consider the operator plus equal to. X plus equal to 5 is the same as x is equal to x plus 5. The addition is performed, and the result is stored in the same variable. Here is a quick demo of the functionality of each of the assignment operators. Comparison operators are used in checking for equality or inequality of expressions. Is equal, is not equal, greater than, lesser than, greater than or equal to, and lesser than or equal to are the comparison operators. Logical operators are used to combine conditional statements. And, or, and not are the logical operators. Note that the operators are denoted by their literals. This is because their respective symbolic representations, ampersand, pipe, and tilde symbols are bitwise operators. As usual, an operation returns true only if both the conditional statements are true. Or returns true if one or both of the statements are true. Not operator reverses the output. Let us look at row number 3. The expression inside the bracket evaluated to false, because x is not greater than y. But the not operator reversed the output, and the final output was true. Identity operators check if the two operands are the same as each other. Instead of checking if they are equal, identity operators check the memory location. If the two operands are in the same memory location, then the identity operator, is, returns true. Let us demonstrate this with an example. We have a list called numbers. It has 3 whole numbers. We create a shallow copy by assigning the numbers list to another variable. In shallow copy, no actual copy operation is involved. The new variable, numbers_shallow_copy, just references the same memory location as the numbers. Any change made in numbers_shallow_copy will affect numbers. Since both numbers_shallow_copy and numbers point to the same memory location, the identity operator, is, returns true. Deep copy creates a replica in a different memory location. There is actual copy involved in this case. Since the two lists, numbers_deep_copy and numbers are at different memory locations, the identity operator, is, returns false. The operator, is not, is just an inverse of the is operator. Membership operators are used to check if an element is a part of a list, set, tuple, dictionary, or a string. They return Boolean values as output. In, and not in, are the membership operators. Bitwise operators are probably the least used. They are used to manipulate operations at a binary level. A very important thing to note is that these work only on integers. Let us try to understand this with an example bitwise in operation. Let us work out the result of a bitwise in operation in steps. The decimal number 5, when written in binary format, is 101. The decimal number 4 becomes 100. Now we compare the binary numbers, bit by bit. And will return true if both the bits are 1. So, 1 and 1 will return 1. 0 and 0 will return 0. 1 and 0 will return 0. So the resulting number is 100, which when converted back to decimal representation, would become 4. The same process applies for bitwise OR, bitwise XOR and bitwise NOT. Left shift and right shift operators are a little bit tricky. Left shift moves the binary number to the left by n bits. N zeros are added at the right end, and n bits on the left end are dropped. Right shift moves the binary number to the right by n bits. N zeros are added at the left end, and n bits on the right end are dropped. There is rarely a scenario where we use the operators in isolation. Most real-world expressions are complex, having multitude of operators. Python has an order of precedence of operators. Parentheses are always evaluated first. Exponentiation comes next, and so on. Refer to this table for the entire order. If two operations at the same level are encountered, the expression is evaluated from left to right. In other words, the operator on the left is evaluated first. Now that we have covered operators, let us move on to decision making. Python has only one statement for decision making or branching. If elif-else statement. Elif and else are optional. Here is a very simple program to check if a number is even or odd. If the condition returns true, the if part is executed. If the condition returns false, the else part is executed. Note that there are no braces. Indentation is used to determine the scope of the code block. As we already discussed, empty sequences, strings and zeros evaluate to false. Looping is a programmatic way of repeating an action for a number of times. Python has two loop statements, for and while. For loop is typically used to iterate over a sequence, or execute the loop for a fixed number of times. While loop is used to execute the statements as long as the condition returns true. As a unique feature in Python, these two loops have an optional else statement. This else statement is executed only when the loop is completed without breaking. Let us understand this through an example problem. The idea is to check each element in the list of fruits, and see if the target fruit is in the list. If not, the program has to print, not found. The for loop iterates through each item. The loop variable fruit will contain the name of the fruit. We match it to the target fruit, and break the loop if the target is found. But if the fruit is not found, we have to print that the target is not found. This is where the else part comes in. The loop will not break, as the target fruit is not in the list. So the else part will get executed, printing that the fruit was not found. The next example with while loop does the same thing. Only the syntax is different. In the case of for loops, the loop variable contains the name of the fruit. In the case of while loop, the name of the fruit has to be obtained by indexing the list. It is vital to properly implement the termination condition for a while loop. If not properly implemented, the loop may run indefinitely. Let us quickly summarize what we have learned today. Today we learnt about the different types of operators and their order of precedence. We learnt about if-elif-else statements, which are used for decision making. We also learnt about looping statements, for and while, and a unique additional functionality in the form of else statement. In the next video, we shall look at these interesting features available within Python. Until next time, happy learning!
Thank you.